So good morning, students. In interpolating techniques, we have seen Newton's forward and backward interpolation formula, which is used for equally spaced data. The third formula is Lagrange's interpolation formula, which can be used for both, that is equally spaced as well as unequally spaced values of x and the corresponding y. We have solved one example on Lagrange's interpolation formula to find value of y at given x. Again, there are varieties of examples, varieties of things which we can find using this Lagrange's interpolation. One is to find the formula or any polynomial of y if you have given the data. If you know only the data and if you want to find the formula for y or the corresponding polynomial for y to study further for the characteristics of that functions, then we can find using this data. Even we can do it for using Newton's forward and backward interpolation formula, but compulsory the data should be equally spaced. Here it is not necessary. Then secondly, we can find its partial fractions. If you are given some function in which numerator and denominator are polynomials, then we can, and if the denominator can be factorized in a linear factors, then we can write it in the form of partial fractions. So let us do this first example. See the example on the board. So you can see here this example in which we have to find the polynomial using this data. Here values of x are -1, 0, 1, 2. Now here by here this data is equally spaced, so here we can use it using both, means forward, backward as well as Lagrange's interpolation formula. But as we have to see the technique of Lagrange's interpolation, we will use here the Lagrange's interpolation formula. Okay. So now let us write now how many values here, this corresponding values of x0, x1, x2, x3 are given, y0, y1, y2, y3 are given here. So let us write down the formula, Lagrange's interpolation formula. Lagrange's interpolation formula. Write only the terms up to which we have given the data. So it is yx, x minus x0. Here in the first term, it will start from x minus x1, x minus x2, x minus x3. Every time you have to write the formula. Let me write it. Y0 plus second term x1 minus x2, x1 minus x3, and y1 plus x minus x1 and it will be x minus x3 as we are writing it for y2. So x2 minus x0, x2 minus x1, x2 minus x3, y2, and the last term here x minus x0, x minus x1, x2 upon x minus x0, x1, x2, x2, y3. Now here, as we want to find the formula for x is the variable here. So we have to put x as it is. So let us substitute the values. So therefore yx is equals to, now x 0, because value of x1 is 0. Then x minus 1, x minus 2, and here now directly I will do the calculations. What is value of x0? x0 is 1. So now you have to substitute x equal to 1 here. So sorry, minus 1. It's sorry, here value of x0 is minus 1. So here it is minus 1, then minus 2 and minus 3. And what is value of y0 is 1.
So directly substitute the values plus x minus, now here x minus x0, but x0 is minus 1, so here you will get it plus 1. Then x minus, now we are writing it for this term x1, so x1 term will not be there. So x minus 1 and x minus 2. Now what is value of x1? X1 is 0. So here 1 minus 1 minus 2 and corresponding value of y1 is 1. So put it in the bracket plus next. Now we are writing it for y2, that is corresponding value of x is x2. So x plus 1, here x minus 0 and x minus 2.
What is value of x2? Value of x2 is 1. So it is 2, 1 and minus 1. And corresponding value is y2 is 1. Then next, x plus 1, x minus 0, x minus 1 upon, now value of x3 is 2. So here you will get 3, 2, 1 and corresponding value is minus y3. So now first of all, we will calculate the constants here. So as now we will not consider here separately this term. While calculating value of this y at some certain x, we consider separately value of this means L0, L1, L2, L3. But now we are interested to find value of means here coefficients of that powers, means here actually n equals to 3, so you will get a cubic polynomial here. So let us calculate this constant. So what will be this sign? First we have to check the sign of this. Then the sign of this here minus minus minus. So here that sign will be minus because here it is plus. And what is it? The constant is minus 1 upon 6. Let it be as it is. X. Simultaneously you can multiply these two brackets, but let me write it. It depends on your skill of calculation. Simultaneously, you can multiply these two brackets so that one step we can avoid. But let me do it stepwise. Plus, now next is here minus minus plus. So, and the constant is 1 upon 2. And the terms are x plus 1, x minus 1, x minus 2. Next term. Here it is minus, so it is minus 2 and it is minus 1 upon 2. The terms are x plus 1, x and x minus 2. And the last term, again minus 3 and this 3. So sign is minus for the ratio, but 3 will get cancelled and it is minus 1 upon 2. So here x plus 1, x and x minus 1. Now, we will multiply two brackets of each term and then we will collect the coefficients of the powers of x. Let me rub this. So now, this constant will be as it is. Put it in bracket. Now I am multiplying the corresponding two brackets. Now x minus 1 into x minus 2. Square minus 3x plus 2. This first term we are doing. Here x minus 1 into x minus 2. So square minus 3x plus 2. Now here next. So this is easy for me. Plus 1 into x minus 1. So let me do it. Plus 1 upon 2 and compulsory write it one by one on next line. Do not write it on one line. It is very easy to collect the coefficients. Then here it is
x square minus 1 into x minus 2 plus, see, I'm not opening this bracket, I'm keeping it as it is. It is safe for us. When we collect the coefficients, we can pick up these terms properly. Then here, x I will put it as it is and I will multiply x plus 1 into x minus 2, which is x square minus x minus 2. And the last term, minus 1 upon 2, then x, and here x square minus 1. Okay, so now the remaining multiplication I will do here. So this is minus 1 upon 6 x cube minus 3x square plus 2x plus 1 upon 2, and here it is x cube. So I am multiplying by x square to this bracket. So x cube minus 2x square and then minus x plus 2 plus
minus 1 upon 2, and here x cube minus x square minus 2x plus minus 1 upon 2 x cube minus x. And now easily we can collect the coefficients of, now I can see here the maximum power of x is 3. Then I will collect coefficient of x cube first, then x square, then x, and then the constant term. So let us collect the coefficients. Properly do the calculations. Here calculations is a very important part. So let me collect it now. So I will collect now coefficient of x cube. So what is it? First minus 1 upon 6. Here it is plus 1 upon 2. Then here it is minus 1 upon 2. And the last term again it is minus 1 upon 2 x cube. Again write it on the next line. So that here. Now next I will collect coefficient of x square. Right. So here minus 3. This minus and minus will become plus. And 3 upon 6 is 1 upon 2. Now that much you are expert to do this. Then in this next one, what is coefficient of x square? Here there is minus, here there is plus. So it is minus 1. 2 and 2 will get cancelled. So it is minus 1. Here what is coefficient? Minus minus plus. So plus 1 upon 2. And then here, what is coefficient of this? There is no term of x square. So only this is the coefficient of x square. Then coefficient of x. So here it is minus 1 upon 3. Right? Here it is 2. Here it is minus 1 upon 6. So it is minus 1 upon 3. Then here it is minus 1 upon 2. Here it is minus minus plus. And you will get it here 2 will get cancelled. Here it is plus 1. And the last term here you will get plus 1 upon 2. This we are collecting coefficient of x. And now the constant term. And now the constant term is present only here. And it is 1 upon 2 into 2, that is only 1. That is plus 1. Right? And now it is in the first bracket, this plus 1 upon 2 will get cancelled. And minus 1 upon 2 is minus 1 upon 6 minus 1 upon 6 minus 3 upon 6. So it is 6, that is minus 2 upon 3. So minus 2 upon 3 x cube. Now x square. 1 upon 2 is plus 1 and then it will be 0. So there will be no term of x square. Coefficient of x square is 0. Now coefficient of x. 1 upon 2 will get cancelled. And now minus 1 upon 3 plus 1 is minus 1 plus 3 upon 3, that is 2 upon 3. So though you are very confident, you please do the calculation here by drawing one line and do the calculation here, though it is 1 plus 3 or very simple calculations to avoid the mistakes.
That is because very important part, calculation part is very important. Plus 2 upon 3x and it is 1. So now how to check whether now this is the polynomial. Now how to check that whether our polynomial is correct or not.
So take any point of x, value of x, and uh, take value of x and substitute in this formula and check whether we are getting corresponding y or not. So you can check it. So if you put x equals to 0,
right? What is corresponding value of x? Sorry, y? 1. Corresponding value of y is 1. So it is verified.
Let us take x is equals to 2. Corresponding value is, I think, -3. Is it? Yes, it is -3. Let us check whether we are getting it or not. So here if we put here -2 upon 3 into 8 plus 2 upon 3 into 2 plus 1. Then it is -16 upon 3 plus 4 upon 3 plus 1. So here it is -12 upon 3 plus 1. That is -4 plus 1 is equals to -3. So yes, we are getting value of y as -3. So our polynomial is correct. So in this way you can verify your answer. So this is one form of example based on Lagrange's interpolation. Now let us see the next type in which we can find the partial fractions. So fractional function is given in which numerator and denominator are polynomials. Yes. So using Lagrange's interpolation formula, express this rational function x square plus x minus 3 upon x cube minus 2x square minus x plus 2 in the partial fractions. In the partial fractions. Now for this, first of all, we have to factorize the denominator. We have to find linear factors of the denominator. Okay. So let us consider this polynomial. Now here we are using the synthetic division. And you know how to do using synthetic division. Let us see here. So first factor we will consider, that is, suppose I will consider x minus 1 is the factor. That is x equal to satisfy this. So I should get remainder 0, right? So for the synthetic coefficients of this, now I am considering the denominator. Let me write it properly. First, we find linear factors of x square minus x plus 2. This we can use only when the denominator can be factorized in linear factors. Okay.
So let us check whether x minus 1 is factor of this polynomial. So for this we will put x equals to 1, and now in this we will write in the synthetic division we will write all the coefficients of this polynomial in the decreasing order of
power. So first I will write the maximum here, x cube, coefficient of x cube is 1, then coefficient of x square is -2, and then coefficient of x is -1, and the last term is 2. If suppose any term is absent, then you have to write here 0. But compulsory all the coefficients in decreasing order must be there. Suppose the term of x square is not there, then you just do not skip it. Write there 0. Otherwise your answer will be wrong because it is there when the calculations were done.
So now here this 1 you have to put it as it is. Now multiply this 1 and 1. Now here in synthetic division we add the terms. So -1, the addition is -1. Now 1 into -1 is -1. Adding it, -2.
Then -2 into 1 is -2, and then adding it. So here if we get 0, so now here we are getting 0. It means that x equal to 1, that is x minus 1 is one of the linear factor of this polynomial.
And then how to write the factors? So therefore, x square x cube.
As soon as we can find one factor, it is easy to find factors of the quadratic polynomial. X cube minus 2, x square minus x plus 2 is equals to, now one factor we have confirmed that it is x minus 1. And now how to write down this remaining? Actually, this is a division that we are dividing x by x minus 1 to this polynomial. And the remaining how to write? So always when you write the term which is just near to this, means previous term here. This is always the constant term. Then this is coefficient of x and this is coefficient of x square. So this quadratic polynomial is x square minus x minus 2. And now it is easy to factorize this. So the factors are x minus 1, and now I think here it is x plus 1 and x minus 2. Yes. So in this way we are getting factors of the denominator. Now what to do? We have to create the data because data is not given. To use Lagrange's interpolation formula, we need the data. Value of x0, y0, then x0, x1, x2, corresponding values of y. Then what to do?
So here for this, we will consider this function as y. And the values of x
are the values of equating to 0. Means here x equal to 1 is one value, x equal to minus 1 and x equal to 2. You can write it in that order only or increasing decreasing order. That is not the issue. So let's here yx is equals to, always take numerator as yx. And now we will create the data. So at this corresponding values of x, we will find, means at these values of x, we will find corresponding y's, which will form our data. So let's, and x is equals to 1, minus 1, 2. You can write it as minus 1 and 2. That is not the issue. Write it, but better we write it in the increasing order. So, make a table. Here it is minus 1, 1, and now find the corresponding value of y. This is equal to minus 1. What is y of minus 1? Here we are using this. So it is 1. Minus 1 square is 1. Then x is minus 1, minus 3. So it is minus 3 here.
So this is my x0 now, and this is y0.
The next we put x equals to 1. So 1 plus 1 minus 3. That is 2 minus 3, which is minus 1. So this is x1 and the corresponding value is y1. Next, y2, that is 4 plus 2 minus 3, that is 6 minus 3, 3. This is x2 and the corresponding value is y. And now apply Lagrange's interpolation formula. Let us write down the formula first. Only two terms are there, means up to y2 is there, so we will write it up to y2 only. Lagrange's interpolation formula is yx is equal to x minus x1, x minus x2 upon x0 minus x1, x0 minus x2 into y0. So only two terms will be there. Plus, let me complete it. Yes. And now just you have to substitute the values. So automatically we get the fractions, means the values of that constant. Generally, when we do it other way, what we do, we factorize this and then we write it a upon, now the factors are x minus 1 plus b upon x plus 1 plus c upon x minus 2. And then we find LCM of these and then again put x equals to 1, then x equals to minus 1, then x equals to 2 to get values of this constant. But if it is up to only two terms, it is okay. But if it again third factor is there, it will become, the calculations are little bit complicated. But here easily you will get the answers of this, means values of this A, B and C. Let it be for our sake of convenience. I will write it here. So now yx. Now let me write what is my yx here. So yx is x square plus x minus 3. Numerator is equal to, substitute the values. Then here it is minus 2 and minus 3 and corresponding value of y0 is minus plus. Then value of x1 is 1. So here it is 2 minus 2 and value of y1 is minus 1 plus value of x2 is 2, 3, 1 and y2 is 3. Again you select the coefficient and then brackets don't multiply, put it as it is. So this is equals to, now minus minus plus, but here minus 3 is there, so minus sign is there for the constant. So I have written the sign first and now check the calculations. Now 3 and 3 will get cancelled. Only here you will get it is as minus 1 upon 2. Put it as it is. Do not multiply them. Then here minus 2 you will get and here minus, so it will become plus. So plus 1 upon 2 x plus 1 x minus 2. And the last term 3 and 3 will get cancelled. So coefficient is 1. So no need to write that 1.
So this is value of what? X square plus x minus 3. Now we want to find the partial fractions. So what we'll do? We will divide both sides by this polynomial, that is denominator, that is x cube minus 2x square minus x plus 2, means we are dividing by x minus 1 into x plus 1 into x minus 2, because that are the linear factors for this polynomial. So divide both sides by x minus 1 into x plus 1 into x minus 3, which is nothing but this polynomial. Let us complete it. X square plus x minus 3 upon
X plus 1 into x minus 2. So we will divide throughout. Now this constant will be as it is. Now as it is the first term, I will write here this term. What is the first term? X minus 1, x minus 2. And we are dividing each term by this product. So look at here, automatically the two factors is getting cancelled and only one factor will remain every time. So here x minus 1 and x minus 2 will get cancelled and only here 1 upon x plus 1. That is what is value of b here now. As we say b is minus 1 upon 2. So plus 1 upon 2 x plus 1 x minus 2
upon
and now the final answer is minus 1 upon 2. This is my value of b, the corresponding constant, and here 1 upon x plus 1. Now here x plus 1, x minus 2 will get cancelled and only 1 upon x minus 1. And the third factor here is 1 upon x minus 2. So therefore, it implies b is equal to minus 1 upon 2, a is equal to plus 1 upon 2, and c is equal to 1. Which we do means we can now say that the partial fractions for this rational functions can be written in this way, and these are the values of the constants. So using Lagrange's interpolation formula, we can find value of the function as given x. Then we can find the formula for y. And also we can find the partial fractions of the function. These partial fractions can be done only Lagrange's interpolation. Here, because we don't know whether we are getting equally spaced, means the factors of this denominator are we spaced or not. But trying to get value of function and from x, if the data is, we can use both of the formulas, Newton's interpolation formula or Lagrange's interpolation formula.